All right, so our objective today is to solve quadratic equations by graphing. And so when you are solving by graphing, you are trying to find the x-intercepts of the graph. So remember that x-intercepts, there's a lot of words that mean the x-intercepts. It can be a solution, it can be a root, and then sometimes we can't find exact roots from the graph. So when those happen, we're going to be using the table. We're going to do some new things with the table today. How many of you already know how to use the table on your graphing calculator, the table feature? Okay, so that'll be new for all of you. All right, and then when you are finding the solutions, you can have two solutions, you can have one solution, or you can have no solution. So for the two solutions, that means the parabola is going to cross your x-axis twice. Okay, so we're going to draw an example of that. If it is a one solution, that means the vertex is on your x-axis. Okay, so if you have one solution, the vertex is on the x-axis. And then if there's a no solution, it does not cross the x-axis. Okay, so draw an example of each of those in there. All right, so what we're going to do is we're going to use our graph to find your x-intercept. So if the vertex is on there, you're going to have one solution, and then if it's above the x-axis and it's opening upward, there's no solution, or it could also be below the x-axis and then opening downward. Okay, so our whole goal today is going to be to find your x-intercepts. All right, and then after you have those written down, I want you to take a look at example 1A. So it says, use the related graph of each equation to determine its solutions. Well, we just talked about the solutions are the same thing as what? The same thing as the x-intercepts, okay? So, Dom, when we're looking at this graph, what are our x-intercepts? What did you find?
Negative 1, 0, and 4, 0.
Good, so you have negative 1 and 4. Okay, so when you're finding the x-intercepts, you're just going to write your answer as x equals negative 1 and x equals 4. Okay, so you're just going to write them as x equals for this. I don't want you to write them as points because we're going to transition into some other things and we'll be writing them as x equals, okay? All right, so then for part B, it says solve the equation by graphing. So last week we talked about how the first thing you want to find when you're graphing a quadratic is the what? That's the first step that we did last week. Yep, and that's because that you're going to find what? What does that tell you? The x-coordinate of your vertex. Great. Okay, so we're going to do the opposite of B over 2A. We're going to simplify, and then once we do that, what do we do with that value? That, yes, and then on our table, where does it go? In the middle. Okay, so this is negative 2 divided by 2, which is going to be negative 1. So we put that in the middle of our table because that's the vertex. And the vertex is the axis of symmetry. This is your axis of symmetry. Okay, and then yeah, so last week what we were doing is we were plugging this in for x to find y. I'm going to show you a new way to do this. after we find the y-coordinate of the vertex. So last week we were using mental math. -1 squared is 1, 2 times -1, -2 plus 1. So do you see how we have 1 and then -2? That's going to be 0. Right? Today I'm going to show you how to use the table feature. And you're going to love it. Okay, so the table feature you can use, and it will tell you what your y-coordinates are. And that's why you're going to love it. Okay, so what we're going to do is we're going to plug this into y1. So we're going to do x squared plus 2x plus 1. Okay, and you may have noticed here that this says table on it. Also, I'm going to go to my table set because I was doing some other things, but the chances are if you go to second table set, you guys should have 0 and 1 already. Do you want to double check that for me? If you know you aren't using it for any other classes, then you should be fine. But then when you go to your table should match mine. Okay, so if you look here, what we did last week is we just went 2 up, which would be 0, 1, and we went 2 down. The nice thing about this table is now we can find points pretty instantaneously, and then we can put as many as we need to fill the graph. So at 0, I'm at 1, which I knew anyway because that was my y-intercept. At 1, I am at 4, and then do you see here how the 2 is at 9? That's going to fit on our graph too, so we're going to want that on our graph. So you're going to go to second, and then if you hit this graph button, see above it, it says table, and then you should be right there. So it's the second button and then the graph button. Okay. If you are not getting the right numbers, the first thing I want you to do is I want you to check your y equals. And then if you are able to fill out your table with me, will you plot that on your grid and make sure you connect that with a curve? Okay, and again, we're also going to plot the -4, 9. You always want that to stay in your grid. All right, and then when you are plotting your points, I like to start with my vertex, so -1, 0. Then you have 0, 1, 1, 4, and then you want to put this on there too. You want to span your entire graph. Remember, you can also use your axis of symmetry because this is the center of the graph. So they're all going to be symmetric about that point. And then we're going to curve. And I like to do each side separately. I just usually graph better that way. You want there to be a nice little curve here. Okay, a nice U shape. Okay, and it does say to solve the equation by graphing. So just like we did in example 1a, you are going to find the x-intercept. Okay, and then, Sarish, when you have it, will you tell me what your x-intercept is? Great. Okay, so your x-intercept is going to be your final answer. All right, what questions do you have for me on the front side? Okay, so the front was a lot of review. On the back, we're going to be getting into tables. Okay, so we're going to be doing a lot of work with tables today. Okay, so for example 2, it says use a quadratic equation. So when it tells you to use something, we have to have that in our work. Okay, we're going to be doing a lot of things this year where there's multiple methods. So we want to make sure we're following the directions there. And it tells you that you want to find 2 real numbers says they have a sum of 4 and a product of negative 96. So what does a sum of 4 mean? When you add them together, you get 4. The product means, yep, when you multiply them, you get negative 96. So like I just said, there are ways that you can guess and check for this. There's an infinite amount of values that would add to 4, but there is a limited amount of values that would multiply to 96. But since they asked us to use a quadratic equation, I'm going to show you how to set that up. Okay, so we have to see that in the work. So when you're trying to find the two real numbers, you're going to let one of those numbers, it's an unknown, so we're going to let it be x. So we're going to let x equal just one of the numbers. Okay, so based on that, based on what we already know, like the sum is 4, we're going to be able to write another expression. So one of the things we're going to use is x. Okay, and then since the sum is 4, the other number can be written as, and we're going to figure that out together. Okay, so let's say I told you that one of the numbers is 3. You would know the other number is what? 1. How did you get that? If I told you one number was 3, how would you know the other one was 1? Subtract what? That would give you negative 1. Or 3 from 4, yeah. Would be, so if you did 4 minus 3, that would give you this, right? Okay, so I told you that it was 3. If I told you it was 2, the other one would be 2. And then again, it would be 4 minus 2 equals 2. Okay, so I gave you one of the numbers, and you did 4 minus that number. So do you guys think you could tell me what the expression is? Yes, great. It's 4 minus x. Okay, because all we did is I gave you the number, right? So instead of the number, it's just x. Bless you. I get a front seat for it. Okay, so you have the 4 minus x as your other value. So what we also know is that the product is negative 96. Bless you. Okay, so the product is equal to negative 96. Okay, so now we have the two values for the numbers. You have x, and product means that you're multiplying, so we just do x times 4 minus x is equal to negative 96. And we can simplify that to make the quadratic equation. Okay, so to simplify, Brooke, what am I going to have to do to simplify this out? Distribute. Good, so we're going to do 4x minus x squared equals negative 96. Okay, and then from here, it really doesn't matter what side you get it on, but if you're like me, we like to make that first value a positive. So I'm going to add x squared to both sides. Like I said, there are going to be two possible answers for this because you could have the opposite of all of these values. So if I do that, I have x squared minus 4x minus 96. It said to use a quadratic equation. So this would be part of your work, the quadratic equation. Okay, and then what we can do now is just use the table on our graphing calculator to locate the x-intercept. So if I'm locating the x-intercept, what are you going to see in your table? What are you going to be looking for? Close. Yep. Okay, so you're going to look to see where y equals 0, because for every single x-intercept, your y value has to be 0. Okay, so we're going to plug in to y1 x squared minus 4x minus 96. Okay, and then we're going to use our table. Okay, so I'm going to go to my y equals, and then if you want, you can just replace this with the minus 4, and then the minus 96. All right, and then I want you to go to your table, and I want you to see if you can find that. Okay, so remember, to get to your table, you hit the second button, and then the graph button, because above the graph button it says table. Okay, and then we're just going to draw a little table here. All I want you to put in your table is where the y values are 0. And we're looking for 2 numbers, so you should have 2 values there. Okay, did we find any of them?
Please send interruption at this time. If you're a sophomore and it is student ID or have not had your picture taken for the yearbook, please report to the Viking ramp.
All right, so where's one of the zeros? Did you guys find it? Yep. Okay, so which one did you guys find first? The 12? Okay, so if you found the 12 first, that's what I have up here on my screen, the 12 0. Remember, you know the sum is 4. So what could you add to 12 to get 4? Negative 8. So we can just verify that. And then if you found the negative 8 first, you could do the same thing, right? What plus negative 8 is going to get you 4? And then you can verify it that way. Okay? So you're going to have those 2 values in there. Again, you're just looking for the 0. Okay? I usually put like a break in the graph if there's one. Okay? And this isn't something that you have to write out this part when you're doing your homework. I just want you to have a visual reminder of how we found these 2 values. So then your solution is just negative 8 and 12. Those are your 2 numbers. Okay, so you're looking for the x-intercepts in your table. So we found it in our table. If you scroll down to 12, you'll see that in the y column, see how it's 0?
Yeah.
Yep, that's how we found it. So we're just looking for the y coordinate that's 0.
Right.
Yep, that's going to be your x-intercept. Okay, and then we're going to put a little side note here that's going to lead to some of the other things that we're doing today. So if you use your calculator for other classes, you might change your table. We're going to change our table later on today. Okay, so I'm going to tell you how to set your table mathematically. Okay, so there is a button on your calculator that says TBL set, and that stands for table set. So can you find it? It's above what button? The window. This is a cool button because it allows you to start anywhere you want at any value. Okay, and then we are going to be changing it, but you're going to want to also change it back. So we're going to go to second window, and you can see here it says table setup, TBL start. So a lot of times we want the table to start at 0. That's just a common thing to start at. So if you ever change your table, this is going to be the standard table. And then there's this little triangle there that you may have heard of as delta, but do you guys know what it means? The change. So the triangle here means the change in your table. In other words, what do you want your units to go by? And again, a lot of times we use something standard, and that is 1. Often we go by ones. Now that's really helpful when we have answers like this, like -8 and 12. Do you guys know what kind of numbers those are? Integers, yep, positive and negative whole numbers, right? Okay, so it's really helpful when we have those, but as we know, life can't always be this simple, right? We're going to have some decimals that we're going to have to look at, and so we're going to be changing this, okay? All right, so before we get into that, we're going to look at a given table. It says use the table to determine the location of the zeros, okay, of each quadratic function. Remember when they say the word zeros, zeros just mean you're looking for what? Zeros are the same thing as the what? The intercepts, yep, your x-intercepts. Okay, so zeros are your x-intercepts. Then it says state the consecutive integers between which the roots are located. Now again, there's a word in there that's the x-intercept and a 0. You guys know what word it is? X-intercept, zeros, and roots. Okay, so those are all the same thing. There's also some big vocabulary here. The consecutive integers. We just talked about integers are positive and negative whole numbers. If something's consecutive, what does that mean? Yeah, next to each other. Okay, so depending on what the table gives you, they may be a couple of units away, but they are going to be in numerical order. Okay. All right, so what we're going to do is we are going to look at your values. You have your x and then you have your y, okay? When you are trying to find the x-intercepts, before we were looking to see if the y value was what? We were looking to see if the y is 0. Are any of the y 0 there? No. So that means we're going to have to find the integers that they are in between. So what we have to do is we have to look for sign changes. Okay, so we have to look for changes in signs. And that means you're looking for a value that goes from positive to negative or negative to positive. Okay, and you're going to look for this in the y coordinates. Okay, and this is the reason why. If you are looking for changes in signs, okay, with your y, we're going to think about our graph, okay? You don't have to write this part down. I just want you to understand why this works the way it does. So if you change from a positive to a negative in your y, okay, here's a positive y point. Let's say here's the negative. What happens if you go from the positive to the negative? It crosses your x-axis at some point, right? The y value is 0 at some point. And then if you go from that negative back to a positive, oh, there you go, you cross it again. So the reason why you're looking for that change is you're looking to see when it crosses the x-axis. All right, so let's find some of those changes. All right, Logan, can you tell me one of the changes from a positive to a negative or a negative to a positive? Okay, yep, so in your y's, you'll see the 16 and -2. So that changes from a positive 16 to a -2. So what this means is this crosses the x-axis between, and like Logan mentioned, it's between your two x values. So this means it crosses the x-axis between -7 and -5. So when you're writing your answer, one of your answers is just going to be between, and I'm fine if you abbreviate, if you put BTW, -7 and -5. Okay, and then Nina, where's our other change? Yep, -8 to 6, great. Okay, so you go from a negative to a positive. So again, you are looking at your x values. Okay, so when you are trying to find the x-intercepts, you're using your x values. So your answer for that is just going to be between 1 and 3. Okay, so when you're doing your practice problems, this is all that you have to write when you're given the table. Okay, it's just your x values. All right, any questions for me on your table or what you're looking for? All right, then we will venture on to part B. So we are going to use a table to solve each equation. So again, it's telling you to use something specific, so we are going to be using the table. Remember I said there are multiple ways to do this. Right now we're practicing with the table. And if the exact roots can't be found, approximate the roots to the nearest hundredth. Okay, so we've actually already practiced finding roots that are exact on the front page and in our example up here, right? Those were whole numbers. That's not always going to happen. Okay, so we're going to start by plugging this value into our y1. So you always have to plug that into your y1. And I'll show you how to insert something without having to clear it if you want to. So do this with me. So go to y equals. So we're going to go to second. And then see this, this is DEL for delete. The INS is insert. So if you insert, you can do -2. You have to use the negative. If you use the minus, it'll say there's a syntax error. Okay, and then it's plus 3x, and then plus 4, and then you can just delete that last one off. Okay, so make sure that you have the same exact equation in there. Okay, and then we are going to go to the table. And whenever you're going to the table, the first thing you want to do is you want to check to see if there is a y-coordinate that's 0. Okay, so you're going to go to second. You're going to hit the graph button because above the graph button it says table. Okay, so your first step is to look for a y-coordinate that's 0. If there's no y-coordinate that's equal to 0, so if there's no y-coordinate equal to 0, we're going to do what we did above, and we're going to look for the sign change. Okay, the sign changes because there's likely going to be more than one. Okay, so from a plus to a minus. Okay, so that's what I want you to do right now. I want you to go to your table. I want you to scroll to see if you can find a 0, and if not, we're going to find the sign changes. Well, let's look at the pattern, right? Like what's happening here? This keeps going further and further down, right? With no bounce back in sight. So if that's happening, we can also check some of our negative values. -2, -5, okay, and then again, we don't have any in sight, but do we have some sign changes that we can see? Okay, so let's document those in our notes. All right, and then Reagan, can you tell me what one of the sign changes is going to be? Reagan? Oh, it's okay. That's okay. Can you tell me just what one of the sign changes is? In the Y's? Say it again. For
Pardon the interruption. At this time, juniors, please report to the vice room if you need to have your picture taken or need a student ID.
Yeah, so if you can't find any of the y values that are 0, we're just going to look for the sign changes. Okay. Did it? What do you have at -5? Do your numbers match mine though? Okay, so then here we have the negative, negative, negative. So you're just looking when it changes from a negative to a positive. Yes, so -1 to 4. Okay. Okay, so negative to positive, and that occurs at -1 and 0. All right, and then Kinley, what's the other sign change? Yep, so 2 to -5 on your y, and then that will correlate from 2 to 3 in your x. Okay, so once you find the sign change, remember that tells you the values that it's going to be between. Okay, so then here we have this is between -1 and 0. Okay, this is between 2 and 3 for your x's. Okay, and now we're going to talk about how to round that to the nearest hundredth. Okay, do we have questions on this step though? Finding the sign change or the x values? Okay, because now we're going to have to use our table again. Okay, so for our table, we're going to go to second, and we're going to hit the window button. Okay, and we're going to go to that table set. So if you don't have your graphing calculator today, it is very important that you have these. Like I'm writing down the buttons so you know what to do when you're doing this on your own, okay? Okay, so when you go to second table set, it's asking you where you want your table to start. Well, if you know that the 0 is between -1 and 0, what would be a good starting place? Yep, so we're going to start at -1. Okay, so that's your table start. Okay, now you're changing the table. It says to round to the nearest what? It says to round to the nearest hundredth. How do you write 1/100th?
0.01.
Yep, it's just 1 in the hundredths place, right? So 0.01 is what you're going to go by. Okay, so that's the nearest hundredth. If it said to round to the nearest tenth, what would you go by? 0.1. Okay. So we're going to start at -1, and we're going to go by 1/100th. Now remember, what you're looking for is when y is 0, but we are rounding this. So it's not always going to happen where y is exactly 0. So what you have to do is find the y coordinate closest to 0. Okay, and that x value, that is the x-intercept. So you find the closest one to 0, and that x-coordinate is your x-intercept. That is your value.
Pardon the interruption at this time, seniors. If you are in need of a student ID, please go have your picture taken so you can receive an ID.
Yes, teachers are after that. Who's going to teach for me when I'm gone? All right, so when you're finding the y coordinate closest to 0, okay, if you look at these numbers, see how they're getting less negative as you're scrolling down? Okay, and then look, they start going up again. So which one is closest to 0? Which y value is closest to 0? Yep, so look, here you have negative 0.05, and then you have 0.005, and then 0.06. So the one closest to 0 is here. So your answer is the x-coordinate, which is negative 0.85, or just negative 0.85. And that was when y was 0.05, x was negative 0.85. So it does not have to be exactly 0. In fact, you're rounding, so it won't be. You just have to find the one that's closest to 0. And this is going to be one of two answers. Oh, it's just going to round it. So the hundreds here, this is what's going up by hundreds, not the y's. Yeah. The y's will just do their own thing. It'll give you as much as the decimal as it can. Okay, and then for the second one, we know it's between 2 and 3. So where are we going to start our table? We're going to start at 2. Okay, and we're going to do the same thing where we scroll. So second table set, our table start is going to be at 2. We're still going by hundreds because that's what we're rounding by. And then we're going to scroll. So when you're scrolling, you can even just put it in the y's and look at your values. You can see that they're going down, okay? And you know you want to get as close to 0 as possible. So you have 0.5, 0.3, 0.2, 0.1, and then you have the zeros, and then they start going up again. Now, they're not always going to be the same y value. In this case, your y value is the 0.05 again. And then you find the corresponding x value, which is 2.35. And again, that's just because this value was closer to 0 than any other y value. Okay, and you have to find both of your answers there. Okay, can you guys think of other questions you have for me on that? All right, then we're going to learn one more thing today, and that is how to find zeros that are decimals on your graphing calculator. Okay, so when you were graphing, they were nice integer numbers, okay, but we're going to find some that are decimals. So in example 5, it says to use the formula h of t equals negative 16 t squared plus v sub 0 t plus h sub 0, where h of t is the height of an object in feet, v sub 0 is the object's initial velocity in feet per second, t is your time in seconds, and h of 0 is your initial height in feet from which the object is launched. Then it says to round to the nearest tenth if you need to. Okay, so let's look at our story problem. It says Juana throws the ball with an initial upward velocity of 18 feet per second to her friend. So it's an initial upward velocity of 18 feet per second, but the friend misses the catch and the ball hits the ground. Juana releases the ball when her hand is 5 feet above the ground. Use a graphing calculator to determine how long it will take the ball to hit the ground. Anytime they're asking you how long, we need to understand that that means we have to find the time, which is our input value here, the t. So I'm going to show you how to use your graphing calculator to do that. So they give you a general equation and then some more information. So it says the initial upward velocity is 18 feet per second. We know that v sub 0 is the object's initial velocity. So the v sub 0 is going to be the 18 feet per second. Okay, and then the next one is that she releases the ball when her hand is 5 feet above the ground. Okay, so in this case, it says your h sub 0 is the initial height in feet from which the object is launched. So our h sub 0 is going to be the 5 feet. So now we can plug that into our equation. So we have h of t equals negative 16 t squared. Instead of v sub 0, we'll plug in 18. Instead of h sub 0, we'll plug in 5. And then we're going to use the graphing feature to find the x-intercept. And there is a special function that helps us do that. Okay, so we're going to plug it into our calculator, and when we do that, instead of using t, we are going to be using the x values. That's fine. T is a common input used in physics when you're dealing with time. Okay, so I'm going to go back to my y equals. And then enter this in with me. You're going to want to practice this. Okay, this is going to be kind of similar to when we were finding the intersection. Okay, so you're going to go to your y equals, enter that in, and then you can hit the graph button. If you do get an error, make sure your plots are turned off. Make sure you don't have any of these highlighted, or it might say that it can't graph it. They're invalid dimensions. And then you should have something that looks just like this, okay? So what you're going to do is you have to tell your calculator how to find the 0. So you have to give it a range of values. The special feature that we're going to use is found by going to second and then the trace button, which should be familiar because that is where we use the intersect. Okay, above it says calc. Okay, so when you go to second calc, the second one there is 0. So we're just going to hit 2. Okay, and then you can see there's a blinking cursor, and then it's asking you for left bound. So we're going to write this down, and then we're going to do it together. So what you have to do is you have to find the left bound, you have to find the right bound, and then it will ask you to make a guess. The left bound and right bound have to be in certain places or you will get an error. This is not like the other one where you could put the curves anywhere and it would still give it to you. The left and the right bound are going to be important. Okay, so basically what's happening on this graph is you have to tell your calculator, let's say this is your graph, okay? You have to tell your calculator, hey, look between these two values and find where the 0 is. Okay, so if you're trying to find where that 0 is, the left side of this is going to be below the line and the right side of it is going to be above the line. Okay, the simplest way that I have found to explain it to you is to try to get as close to your 0 as possible. So I can't get exactly on the 0, so I'm just going to say that's as close as I can get. For the left bound, you're just going to click it once to the left. Okay, see how it's below the axis? So you're going to press enter. So make sure it's below the axis. Okay, then go back to where you thought was the closest. And now it's asking you for the right. So just arrow it to the right and press enter. Okay, and then technically if you press enter again and you don't do a correct guess, it's still going to give you the right answer, but you can also just go back to your center. Okay, and then it's going to give you the actual 0. Okay, so you have 2 zeros on this graph. The first one, if we round it to the nearest tenth, like it asked us to, is going to be at negative 0.2. Okay, so I just wrote that down there. And then we have to do it again because it crosses the x-axis again. So now you want to tell it, okay, find the x-intercept in between these two values. So when you use your cursor this time and you try to get it close to here, now below is the right side and above is your left side. Okay, so let's arrow it over. Oh, sorry, we have to go to calc first. So second calc, and then press 2 for 0. And now we can arrow it over. So again, I just get it as close to the 0 as I can. And for left bound, just do an arrow to the left, press enter. And then to the right, go back to the center, click to the right, go back to the center, and then it's going to give you the second 0. So if I round, it's going to be 1.4. Okay. If you are getting an error, it's likely because you didn't change the signs. Notice how the left and the right, one is negative, one is positive. One is positive, one is negative. Remember how we were looking for sign changes? You still have to have those sign changes there. Now, because this is a real story problem, we have to reject one of these answers. Which one can we reject? The negative. So time can't be negative. Okay, so when you're doing this on your own, it's okay if you don't find that one, if you just find the positive, and then your answer is just going to be 1.4 seconds, because it says how long, so you have to include your unit with that. You're going to have the 1.4 seconds.